calculate the shaded area. So we're talking all this shade here and here. If a regular pentagon with apothem of 7 meters and one side of a 10.2 and one side of 10.2 meters, as shown below, was inscribed in a circle of radius 8.7 meters. Now go to your formula chart, and we know that we're dealing with a circle and a regular pentagon. Okay, and you look for the regular polygon, which is 1/2 AP, and circle pi r squared. So when you look at this figure, you should clearly see the circle is bigger. So we want the pi r squared first, okay, and then subtract the regular pentagon, which is 1/2 times A times P. Now when you look up here, we see the apothem is 7, so we know that we know the A is equal to 7, and we have one side is 10.2. So we can make ourselves a little note here that the perimeter is going to equal to 10.2 times a pentagon has 5 sides times 5. So we can put that into our perimeter. Our apothem, well, we know the radius. We also know in the reading. One of the things that I want to point out to you that is when you're drawing in this triangle, if you ever had to find the radius, remember from the center drawn perpendicular to one side, you want to stop right here now, because this is your side of the pentagon. You don't want to continue going through. If you do and touch the circle, then you're representing the radius. Now the radius is this piece here drawn to the circle. That's the radius. Now we know that the radius in the reading up here, and I'll go ahead and make a note right here that R is equal to 8.7. okay, we know the radius, underlining or circling these important terms that are in the reading, and that we had one side here of 10.2, and then the apothem here is 7. Okay, those three things were needed because of these formulas are requiring the radius, the apothem, and the perimeter. And then when you look at this, that the apothem is 7, we put that here. We know that the radius is 8.7, that goes over here. And we know that one side is 10.2. I can say, right here, this is 10.2. We know all of these are equal because it says it's regular. So all sides are 10.2. We take one side, divide it by 2 to get that piece, which would be 5.1 if we needed it. We can jot that in, that from here to here, that piece right here would have been 5.1. But we don't need it because everything is given. I just want you to see that the diameter, is from the point on the circle through the center and keeps going all the way through. That would be the diameter. Notice that the diameter is not the apothem in this problem. Now you go in here, and another thing, it doesn't say anything to do in the reading with pi. That means we must use all of pi. So when we write this down like this, we want to make sure and put all of pi into the calculator, and I'll show you here in a minute. But we go pi times radius squared minus 0.5 times the apothem, 7 times, and here's another thing, and this happens to me a lot too. I'll get the side and forget to go have that calculation already in my calculator before I start entering all this, and so you can just fix that right here and put 10.2 for one side and then times the 5. Take care of that right then and there. So then when we go into our calculator, it's straight calculation. So when you go, you know where the pi is located at. Get that, press enter, get all of that. Pi times 8.7 squared minus 0.5 times 7 times 10.2 times 5. Okay, now you can see the answer to this problem would be rounding to the nearest tenth is the other thing we need to remember to do. That would be a 59.3 because the next decimal to the right of 2 as 8, which is greater than 5. We round the 2 up to 59.3. So the area is equal to 59.3 and then meters squared. Don't forget to square that.